All right, so let's try the other half of this thing. So we want to graph r of theta is 1 minus sine of 2 theta and compare that to the graph of the cardioid we got from earlier. So how do I start with graphing a polar curve?
You graph the sine first and shift it.
Okay, so we're going to start by graphing everything in the theta r plane, right? So how does this 1 minus sine of 2 theta look?
So sine waves squished by 2 and up 1.
You guys cool with that? So sine wave flipped over, squished by 2, shifted up a unit. All right, so midline's going to be at 1. It's flipped over, which means it's going to go down to begin with. Okay, cool. What does squished by 2 do?
Cuts everything by half.
Cuts everything in half. So this guy's normally at pi, right? This first crossing in the midline. So now it's at pi over 2. And this return through the midline, right? That's 1 period. That's normally 2 pi, and now it's pi. And then we'll go through another period between pi and 2 pi, right? You guys see that? Okay, so now I think I need to straighten out how this looks. So this first interesting point, that's going to be associated to an angle of what? Okay, pi over 4. Okay, so now I need to cut my shape, right, my polar graph paper. So I make my circle of radius 1, I make my circle of radius 2, and now my angles that I'm going to be interested in are between 0 and pi over 4, right? And then between pi over 4 and pi over 2, and then between pi over 2 and 3 pi over 4, so forth. So what do I need to add to my paper here? Where's the angle pi over 4 on here?
Oh, you need more.
Yeah, I want to kind of put those angles on here so I can keep my picture straight. So my angle pi over 4 is here. Pi over 2 is this guy. 3 pi over 4 is going to be over here. Throw that in here. And this will be a, what? Pi. Cool. All right, so let's see if we can draw this first thing. I'm going to draw this new picture in blue. So we start where? Yeah. R is 1, oops. R is 1, theta is 0.
We start at the same place as that.
So we're going to start at the same place we started the other picture. And then we're going to go to pi over 4, right? And our graph's going to what? What's the radius going to do? Yeah, it's going to go down to 0. So we're going to start here, and we're going to go down to 0. You guys see that? And I have to do all of that in that first little cone, right? Between the angles of 0 and pi over 4. Now what happens between the angles of pi over 4 and pi over 2? Yeah, it goes from 0 up to 2, right? Or 1. Thank you. Right, that's this piece. So that goes from r is 0, doesn't really matter what the angle is, up to here where it's r is 1 at theta is pi over 2. So r is 1 at theta is pi over 2 looks like this. You guys with me? So we're going to get this kind of a thing. You guys see that? Notice this thing probably is kind of cuspy, right? Remember, there's a thing about tangent lines not existing at cusps. So maybe there would be some weirdness going on there. All right, let's see. How about my next interesting point? That's up here. What's that guy? Yeah, good. That's theta is 3 pi over 4. and the R there is 2. Okay, so how do I make that happen?
Plot it and then it'd be increasing to that point.
So, yeah, go to 2 and 3 5.
So I need to go like that somehow.
Yeah.
Okay. Then
3 5 4
this guy is
1. Or 1
at
to 3 5.
R is 1, right? And theta is pi.
So just follow that line of it. Could you?
Follow what?
Like the.
Go back down.
Oh, you're going to the origin.
Back to the origin?
On
No,
no, not the
go to
origin. I meant
first dotted
the
line, right,
x-axis.
on pi.
Oh, I need to go, good, I need to go to the x-axis, right? At -1 on the x-axis. Because I went to the angle pi, oop, and then I want to go 1 out in that direction.
Yeah.
So, for angles in here, I need to decrease, so I get this kind of thing.
What can you do?
You guys see that? That's from the angles 3 pi over 4 to pi. We're decreasing the radius from 2 to 1. You guys with me? Okay. And now I have not gone all the way around this silly picture, right?
Isn't that a full period?
Yeah, so this is a full period of the sine function, right? But I haven't gone all the way around my picture.
The 2
See that? So it's going to take 2 periods for me to get all the way around the picture. So something else maybe is going to happen here. Let's see. So I need to go from pi to, where's this next? Good, that's 5 pi over 4 in angle, right? And the radius there is 0. So where's 5 pi over 4? Oh, I didn't even put it on the picture. Arrogant of me. So there's my 5 pi over 4. And I'll need that other one later. So what do I do in there? Good, I need to kick it back down to 0. So we get something like that. Okay, so I got some little funny acorn thing. Okay, then as we go up to, where's this next one? Where's this dot?
1. R is 1.
Good, that's R is 1, and theta is
3 pi over 2.
3 pi over 2. Okay, so where's that dot at? What are the XY coordinates for that dot?
I'm just gonna one.
It's gonna be on the
It's on the y-axis, right? So the x coordinate's 0, and I'm going down 1, so 0, -1. Boom, dot. And so I get something that looks like this. Yeah, and it seems like it's probably going to be another little acorn thing, right? So can I confirm that here? I need to go from R is 1 to R is 2, right, in the next 8th circle. So R is 1 to R is 2 in the next 8th circle. And then it seems like I probably have to go back. So I got 2 little acorns. You guys see that? And they want me to compare this, and I don't know if they expect me to see an obvious pattern or not.
Lost your butt.
Yeah, it kind of lost the little butt that it had.
Sad.
It's no longer heart-shaped. I don't know what they expected me to observe here, really. They're almost, like, they're a little bit similar, right?
If you smash the 2 of them together, they might look like. If we had a positive one, we put them together, could we have a flower?
Well, we could certainly shift this whole thing a little bit and make another one to make a flower, right? You guys see how we would shift it to make the other, like, say we for some reason wanted to draw this dorky little flower here by getting the acorns pointed the other direction. What would I need?
Y over X or no? How do you?
Flip
Yeah,
X.
I need to,
Flip it and then turn it.
Yeah.
yeah, I just need to
Flip it.
rotate it, right? So I need to change the
Oh, yeah.
angles. You guys see that? So I just apply some horizontal shift in here.
You just flip it over that.
You guys see that?
Can you?
Or,
Oh, yeah.
Yeah, you flip it over the axis.
oh yeah, or we could flip it over the x-axis. So we could maybe do
It's positive sign.
Yeah. One
positive
plus sign,
sign,
two
might
plus.
well do it, yeah. So either a horizontal shift or a flip. Does it make sense that those are the same thing sometimes for sign functions?
Yeah, this isn't sign.
Sign's odd, yeah. Yeah, but a horizontal shift of an appropriate amount could be a flip. Cool. Questions, Steels?